Hello, welcome to this lesson where we want to look at linear programming, and we are drawing the questions from the past exam papers, just like I mentioned in the previous lessons. This is the 5th lesson of linear programming. Remember that the topics are taught in full, just the way they are presented in the Zambian syllabus, mathematics, for grade 10 up to 12. Now, linear programming is a grade 12 topic that comes both in paper 1 and 2. Paper 1 work, we already looked at it. Now I want us to look at how the questions come in paper 2 and how we can handle them. So we have a question with us here, which is in 2019. Okay, this is paper 2, section B. I hope you are able to see the question. Okay, so you should write down the question first. You will copy down the question in full. So this was question 9, as you can see. So you write down the question from there. Then you come down here. Okay. You write it in full. You write the question in full. Okay. So I'll be reading from the question, taking it that you already have the question. Okay. So let's begin. Okay, so I'm going to read the question with you, and I'm taking it that you already have the question and you have copied it. So we are saying, Kunika wishes to build a lodge with single and double rooms. He needs to decide the number of each room type he should build to maximize profit. Let X represent the number of single rooms and Y the number of double rooms. Write the inequalities which represent each of the following. Okay, so I should believe that this being our 5th lesson, we are conversant with all this. We are conversant with all this. These are things that I talked about in detail where we're coming from. So I do not believe that you should have challenges. Please, if you have not, I do request you that go back to those lessons, because this is lesson 5. Go back to those lessons and give them attention. But if you can follow me as I'm going to be presenting this thing and you'll be able to get the concept, please stay glued and follow what I'm doing. Okay? So I did present all these things. So now, how do we write these inequalities here? I did mention and I wrote these things down. You remember the previous lesson where I gave you all these words and their symbols there. Okay, you remember the previous lesson where I gave all these words and their symbols. Okay, I gave all these words, about 12 of them. So let's look at this question. The first question, if you have copied it, I hope you're able to see it. It says, there must be at least one single room. There must be at least one single room. Remember that this question has to be answered on the graph paper. So I'm also going to be to bring a graph paper now and start putting this question on the graph paper. All right? So it says there must be at least one single room. Okay? So I'm going to write these answers on the graph paper, because that is where this question should be answered fully. So the first one, we need to assign variables. I'm sure you know where we're coming from. So we should have X and Y. X is what? X single rooms. X is what? Single rooms. Y is what? Double rooms. Okay, we have assigned those variables. So now we are beginning to write the inequalities. There must be at least one single room. So meaning the single rooms, we need at least one of them. At least one of them. So the inequalities are here. X represents what? The single rooms. So there must be at least, you know what at least means. It should be equal to or greater than 1. Should be equal to or greater than 1. So this is our first inequality. We're going to read the second one. There must be at least 10 rooms altogether. There must be at least what? 10 rooms altogether. So what does this mean? When we add the double rooms and the single rooms altogether, they should be at least, the minimum should be 10. So what are we saying? When we add x and y, they should be equal to or greater than 10. Okay? This is our second inequality. So we go to the third inequality. What is it saying? The total number of rooms should not exceed. The total number of rooms should not exceed. Should not be more than. Should not exceed. I'm taking it that you have been with me from the previous lessons. Should not exceed. The total number of rooms, that is single rooms and double, should not exceed. So they should be equal to or less than 15. Should be equal to or less than 15. That is what we are doing there. All right? Then the last one is the number of double rooms. The number of double rooms must be at least the number of double rooms. The number of double rooms, which is y, the number of double rooms must be at least twice. Must be at least twice. Okay? This twice we encountered it even in the previous lessons. Must be at least twice the number of single rooms. It should be greater than or equal to twice the number of single rooms. These are the inequalities here. These are the inequalities. I hope they are clear and you're able to see them. And this week we did it where we were looking at mathematical models in the previous lesson. Okay? So having done this, you can see yourself, you can see for yourself here, we are remaining with the last one. We are remaining with the last one, if you're able to see it, which says the number of double rooms should not be more than 12. The number of double rooms, which is y, should not be more than. So it should either be equal or less than 12. Should either be equal or less than 12. So these are the 5 inequalities that we were asked in 2019. Okay? Then when we do this, we need now to proceed to the next question. Okay? So these were our inequalities. I hope they're very clear. Okay? So now let's proceed to the next question. I hope you copied the question and there is no, but I'll still, okay? Here, this question. This one. That's the question that we are looking at now. Okay? So, we are saying, using a scale of 2 centimeters to represent 5 units on both axes. 2 centimeters to represent 5 units on both axes. So, draw x and y axis for, that is for the x axis to be 0 up to 16. Okay? Then for the y axis, it should be from 0 up to 16. So, respectively, then shade the unwanted region to indicate clearly the region where the solution of the inequalities must lie. Okay? That is what we are supposed to do now. So, we come to our graph paper. To complete this work. Okay? We go back to our graph paper. Okay, so here is our graph paper. So now we need to write. We need to draw the oh, sorry. I'm using a pen so that it's clearer. So this is our 0. This is our x-axis, and we are told that this 2 centimeter, this is 2 centimeter, these are 2 centimeter boxes. So we're told that each 2 centimeter must represent what? 5. So this one is going to be 10. And then this one is going to be 15. Now we are told it's supposed to go up to 16. So I'll put it 20 here. The same thing going up here. We are supposed to have what? 5, 10, 15, and 20. Okay? We put our y and our x there. This is our graph paper. Okay? So now we want to plot these. Are we together? Take note. So we need to bring these inequalities now on the graph paper. So the first one is what? X is greater than or equal to 1. So I'm bringing you back to this. Where is our 1 here? When you look at 5 here, how do we count these boxes in order to get to 5? So it is like 2 of them, they give us 1. 2 of them give us 1. You can try it on your graph paper. 2 of them give us 1. So our 1 is here. Our 1 is at this point. So we need to draw a straight line now here. Going up, this is the equation. Okay. Have you seen it? What are we calling this in terms of an equation? This is x is equals to 1. This is an equation. But then you remember that we are shading the unwanted region. You remember that we are shading what? The unwanted region. Please take note of that. We are shading the unwanted region. So the wanted region here, we're looking at x is greater than 1. X is greater than 1. So the values of x that we want are these ones that are this side where it's greater than 1. So this side where it is unwanted, we are supposed to shade. We are supposed to shade this part here. We're supposed to shade this part here. You can shade it like this. You shade this part. You shade this part here. The unwanted region. The unwanted region, we are supposed to shade it. Okay? I hope we're following. So we go to the next one. So the next one is x plus y is equals to 10. So when we are dealing with this one in form of an equation, so this one, where we have x plus y is greater than or equal to 10, we need to treat it as an equation. How is it going to be? Like this. Okay? So when we do this, now we need to come up with the, I told you even from the previous lessons that where we have two variables here, we need to come up with a coordinate of what? With a set of coordinates. We have x and y. So I'm going to say, when I put 0 here where there is x, when I put 0 here where there is x, what will be my y? My y will be 10. Then here, when I put 0 where there is y, it's like this y dies out, isn't it? This becomes 0. So what is going to be my x? My x will be 10. So these are the 2 points that we are going to plot now, which is 0, 10 and 10, 0. These are the coordinates now that we are going to go and plot. Okay? On this line. 0, 10 and 10, 0. Okay? So 0, 10 is this point here. This is 0, 10. Then 10, 0, it is also this point here. So we need to join these 2 points now. We join them like this. Please, if you're having complications here, I would request you that you go to the lesson number 2 of this topic. That is where these things were properly presented, like how to come up with, how to put the inequalities on the, how to graph them. Okay, so now when we come back here, what are we saying? Which region is required? The greater part. So the region that we are supposed to shade is the unwanted region. So the unwanted region is this region that is below here. So we are supposed to shade this region. We are supposed to shade this region. This is the unwanted region. This is the unwanted region. Okay, this is the unwanted region here. Like this, you shade this, the unwanted region. Okay, so then we proceed. Again, what do we have here? X plus y is equals to, in terms of an equation. So we go back to that process. We go back to that process where I did advise that, in terms of an equation, you have got x plus y is equals to 15. Okay, so when you come up with the x here and y, when x is equals to 0, y is equals to 15. When y is equals to 0, x is equals to 15. Okay, so these are the coordinates that we are going to plot now, which is 0, 15 and 15, 0 for this line. Okay, so we plot. Where is it? It's here. 0, 15 is this point, then 15, 0, it's this point here. Again, we join these 2 points. Okay? We join these 2 points. We join these 2 points. Now, in terms of an equation, this is what? X plus y is equals to 15. Then this line, in terms of an equation, it's x plus y is equals to 10. Then we go back to the shading part, which represents inequalities now. What are we looking at? The less is the region that we want. So we are going to shade the greater part. So the greater part here is this one. The upper part is what we do not want. So we are going to shade this part. So you shade, this is the part that we do not want. We get rid of this part like this. We don't want this part. Okay, I hope you are following. Okay, we shade. We go back now to the third one. We go back to the third one, isn't it? So this is y. Where is it? This is talking about y in terms of an equation. Y is equals to 2x. I hope you are following me. Y is equals to 2x. Okay, so we are saying this is y is equals to what? 2x. So again, this one we need to come up with the set of coordinates. X and y. 2 are enough. How do we pick those in this case? You can start with 0. If your x is 0, what is going to be your y? It will mean y multiplied by 0. What do you get? 0 also. Then you can come here. We were looking at 0, isn't it? So you can say, what if my x is 5? What if my x is 5? Okay, what do you get? You will see. What if my x is 20? Okay, now let me try 5. You are actually getting these coordinates that are here. You are trying. For instance, if you put 15, you are going to get 30. which is not on the y-axis. So you come down. So let me put 5. This is 5 here. If you put 5 here where there is x, it will be 2 multiplied by what? By x. And this is going to give us 10. So what coordinates are we having here? 0, 0 and 5, 10. So these are the coordinates that we are going to take on the graph paper. Are we together? We continue. So we are saying 0, 0, which is this point here. 0, 0, don't forget, it's the origin. 0, 0. Then we have 5, 10. 5, 10, 5, 10. It's this point here. So we need to draw a straight line that joins these 2 points. This one and that one. Okay? That is what we are doing. Like this. Are we together? Then I'm going to say, what is this? This is y is equals to 2x, an equation. It's an equation there. Then what are we talking about? We want the greater part. So we're going to shade the less part. Which one is the less part? This part that is below here. You shade this part that is below. This is the unwanted region here. This is the unwanted region. This is the unwanted region. I hope you are able to see that the place is coming out. Then, this, if you want, you can go down just to completely close this one so that you don't get distracted. Okay? So, then, what are we talking about? So we now have to go to the last one, which says y should be equals to 12 in terms of an equation. Y is equals to 12 in terms of an equation. So this is what I was saying. When you look at our graph paper, this is what I was saying. When you look at our graph paper, how do we count from 10 to 15? It will mean that these 2 lines, each of these 2 lines will give us 2. Okay? Each of these 2 lines will have to give us what? 2. So I'm going to say this is my 11 is here, so my 12 is here. Okay? My 12 is here. This is my 12. And what are we doing here? Remember, we are saying this is y is equals to 12 in terms of equations. Y is equals to 12. But then what do we have to shade? We have to shade, this is less. So we are shading the unwanted part, which is up. So we are shading the greater part, this one. Have you seen the region that we want there now? It has clearly indicated that is the region that we want. That is where our solutions must lie. This is where our solutions must do what? Must lie. Okay? This is where our solutions must lie. Are we together? This is where our solutions must lie. Okay? So let's proceed. We are supposed to proceed. We are supposed to proceed. Go back to the question. We go back to the question. The last question now. The last question says the rate for each single room is 600 kwacha and 900 kwacha for a double room. How many rooms of each type should Kunika build to maximize the income? Okay? Are we together? I hope you are getting the question. All right. So here we are talking about what? The rooms there. If, for instance, this is a what? A lodge. So if you are moving into a single room, you are going to pay 600 kwacha. Into a double room, you are going to pay what? So we need to come up with what we call the objective function. We need to come up with the objective function or the profit. Okay? So, the objective function is this one. We are saying, you remember, it's 600 for X, which is single room, plus 900 for what? For double rooms. So this is the objective function. This is the objective function. Since this objective function helps us to find profit, if you want, you can actually put, but this is the objective function here. Let's leave it like that. This is our objective function. So this is the objective function. So I wanted to say that if you want, we can actually write that. We can write profit here because it's helping us to find profit. And write profit here is equals to this. Okay. So now the question is that how many of each type, okay, must this person build in order to maximize profit? So this is the region that is going to help us. This is the region that is going to help us. This is the region that is going to help us. Are we together? This is the region that is going to help us. Okay? This is the region that is going to help us. How is it going to help us? We need to identify now. We have to identify all this region gives us the what? This region gives us the coordinates that we may want. Okay? Now, it is easier, we go for those that are in the, let me call these the corners. These corners here. We get the x coordinate here and the y coordinate, also this point, even this point. All these corners here. Okay? We get the x coordinates here, and all these lines we do not have any dotted line. So we are going to pick the coordinates for each point here. I hope you are getting what I'm saying. So for instance, we can start with this point here. What are the coordinates of this point? We have 1. It is coming from 1, isn't it? 1 comma what? This should be 1 comma 8. So the coordinates that we have here is what? I'm going to write, the first one is 1 comma 8. And then the second one is this same one. What was this? This is 1 comma 12. This point here, this is 1 comma 12. So I'll also write it here, 1 comma 12. Okay? Then now we go this way. What is this coordinate here? What is this coordinate here? Okay, here we can actually pick, this is 1, 2, 3, 3 comma 12. This is 3 comma 12. So I'm going to write 3 comma 12. Okay. Then we come to this one here. What is this point? This is 5 comma 10. This is 5 comma 10. Okay. Then we come to the last one. What is this point? This is 1. This is 1, 2, 1, 2, 3. So it's like we have 3.5. 3.5 comma. I'm going to call this 3.5 comma 3.5 comma. Okay, this is 1, 2. This is 1, 2, 3. Okay, so maybe let's pick 3. Okay, let's pick 3. We can't have a point when we are talking about buildings, so let's pick just 3 there. Okay, then that will mean 3 comma what? This is going to mean 3 comma 5, 6. It's going to mean 6, 7. 3 comma 7. Okay, 1, 2, 3, 4, 5. So they're all 5. We have picked all these. That is what you are supposed to do, even in the question that I'm going to give you for exercise. That is what you are supposed to do. Okay, that is what you are supposed to do. So now, after we have done this, okay, after we have done this, what do we have now? We have to go back. Now remember, here we have what? The x coordinate and the y coordinate. What is the x coordinate? The x coordinate is the number of rooms for what? The single rooms. This one is the number of double rooms. So you should know that all these x coordinates here represent what? Single rooms. Then the y coordinate represents what? So this is a combination, okay? A combination of rooms that can be built. Now we want to see which one gives the maximum profit. So what do we do? And how are we supposed to carry out that process? So meaning we are going to be testing them in this objective function now. Are we following? We're going to be testing them in this function. We're going to be testing them, okay? What do I mean? You start with this one. You say 600, you put 1 here, plus 900, you multiply by 8. Are we together? You also come to this one. You say 600 multiplied by 1, then plus 900 multiplied by 12. You come to this one, 600 multiplied by 3 plus 900 multiplied by 12. You come to this one, 600 multiplied by 5 plus 900 multiplied by 10. You carry on with this process. Okay, so this is the process that you are supposed to continue with. Okay, so after this, you need to find now the actual amounts here. So these are the profits now. Now, on the profits here, we're coming from this function. On the profits here, which one is the highest? Which one is the highest amount here? Okay, which one is the highest amount? Which one is the highest amount here? Check these amounts here. Check, I mean this one. Check. Which one is the highest amount? This is 8,100, 12,000, 12,600. So you discover that the highest amount is this one. This is the highest amount. So what does this mean? What does this mean? The question was saying, how many of each rooms must Konika build in order to maximize profit? So I'm taking you back to this. Which one gave us the highest amount? It's this combination of 3,12. 3,12. So meaning, for him to maximize profit, we got the highest amount from this one. So he must build now. He must build it's this question here, isn't it? It's this question here. How many rooms of each type? So you must also be A, okay? This part here was our A, okay? This part was our A. Then the B part was talking about shading. So maybe if you want, we can say B. Then maybe B we can say refer to the region R, okay? So if you want here, we can put region R, okay? To show that this is where the solutions are going to lie. Then now C, okay? All this work here, we're trying to find the final answer for C. So we can say C. The number of rooms that must be built. Single rooms should be how many? Single rooms 3. double rooms 12. Or if you want, you can put it in a statement form. In order for Mr. Kunika to maximize profit, he must build 3 single rooms and 12 double rooms. We have answered this question in full. We have answered this question in full. Okay? We've answered this question here in full. And I hope it has answered all your questions. If there are times when they ask you to, how much is the profit, like what is the profit itself? If there was such a question, the profit was going to be this same question that we got. There are times when they ask you such questions. For instance, in this exam, okay, in this exam, I hope you are able to see this question here. The last question, what was it asking? Calculate this estimate of the maximum profit. So that is what you're going to get in that case after you have found each number of rooms that must be built in order to maximize profit. Okay? So basically this is what we are supposed to know, and I'm supposed to give you the exercise as per our culture. Okay? Okay, our exercise is here. This question here. Okay, so it's the same. The inequalities are already listed, so they are not in the passage, they are already listed. So it's basically, this one is just one inequality here. So what you are going to do here, after you have written this inequality, you need to simplify it. Like, to simplify it, what do I mean? You reduce it. Okay, you reduce it so that it can be accommodated on the graph paper. You have to reduce this one. Okay, I hope it's clear. I hope it is clear. Okay, let me see if there's another one. Okay, there is also this question here. This is I think 2016. So answer this part of the question on a sheet of graph paper. So you copy it, you copy the question, then, okay, not B, leave out the B part. So you come up to this one. Okay, that is what you're supposed to do. Okay, so there's also this one. This was an interesting question. It came in 2004. Just to give you more. Okay. It requires a bit of thinking, which is very good. Okay. So thank you very much for watching. Make sure don't forget to subscribe to this channel and invite your friends that are writing the ECZ exams. We are here to make sure that we help people pass. Once again, thank you very much. Goodbye.